In the last several videos, I've been focusing on DML, or data manipulation language, because in many ways it's easier to learn and understand. In this video, I'll use the methods I've been covering, but apply them to data definition language, or DDL. I've created a new project, which I've called JDBC Challenges with the usual main class. I need to include the JDBC driver again in this project, so I'll right-click and select Module Settings, or in Windows, that's F4 for the shortcut key. Select Libraries on the dialog that appears. Select the plus sign icon and select Java as the option. You'll get a file dialog, and hopefully you'll remember where you downloaded the MySQL connector.jar jar file. I'll select mine and I'll press OK to any dialog that follows. And that's that. Now, I'll go to my main class. I'll set up a static query string, so private, static, final, string, use_schema, and I'll set that to the literal text, use storefront. This statement is a DDL statement. It sets the default database for the session. I'll use this statement to test if I need to create the storefront database. To do this, in the main method, I'll set up a basic data source. Since I'm running in a standalone environment, I'll create a new instance using the class name of the MySQL data source. I'll set the server name, localhost, and the port 3306. I'll set the user to be an environment variable, which I've done before. I'll do the same thing for the password. Notice that here, I'm not specifying any schema or database name when I'm setting up the data source. That's because I plan to create it. First though, I'll set up a method to test if the database exists, so I'll create that. I'll make this private and static and return a boolean. I'll call it checkSchema and pass it an existing connection. It's complaining about the import. I'll fix that in a bit. I'll create a new statement object in a try with resources. I'll execute the use schema statement. If this throws an exception, I'll print the stack trace and return false if I did get an exception. Otherwise, I'll return true. If you get into a situation where IntelliJ doesn't show the import pop-up, do this to force the pop-up. We want to choose java.sql connection here. This should fix the import for statement as well. Scrolling up, you can see it has. Next, I'll call this method from the main method. I use a try with resources to first get the connection from the data source with the getConnection method. I'll execute checkSchema as part of an if condition. So if it returns false, I'll print that the storefront schema doesn't exist. And I'll set up the usual catch clause here. I'll set up my environment variables as part of the run configuration. You've seen me do this several times by now, so I'll just do it real quick. So run, edit configurations. In the environment variables input field, I'll set up my SQL user equal to dev user, then I need to follow that with a semicolon, not a comma. Then I'll type my SQL, PASS, and set that to my password. You'd put your own password there. Now I can run this code. And sure enough, I get unknown database storefront. Now in truth, the code in the checkSchema method is flawed since it just assumes any exception thrown means that the database doesn't exist. A lot of problems could happen here that have nothing to do with whether this database exists or not. The SQL exception comes with additional information we can examine. This includes an SQL state string derived from a list of codes from one of two possible conventions used to standardize codes. To figure out which convention the driver uses, we can query a class called database metadata, which we can get from the connection. Next, there's an integer error code that's specific to each vendor. These codes can often help determine, with more accuracy, the exact error that occurred. Before I add any more code, I'll show you how to get information from the database metadata class. This can be retrieved from the connection object with a method called getMetadata. I'll add this code as the first statement inside the try block. I'll create a variable called metadata, assign it the value I get from the getMetadata method. I'll pause after I type metadata dot. I want you to see the many things you can learn about your database from this instance. If you're writing JDBC code, you really should try to be familiar with your driver's features, and this class and its methods will help you explore the driver configuration and database specifics. In this case, I want to execute getSQL state type, so I'll scroll down and select that. I'll run the code again. Notice that a 2 is printed out before the exception. That's not immediately useful information. I'll control-click on the class database metadata and search for SQL state. Here you can see there's a couple of constant values and the SQL state SQL is set to 2. This indicates this driver is using the latest SQL conventions and not the XOpen conventions. I'll show you how to look codes up using one of these conventions in a minute. First, I'll write some code to explore the error I got back. I'll add this code after the print stack trace in the check schema method. I'll print the SQL state first, then the error code, and finally the message. Notice here, I'm using system.err and not system.out, which I don't think I've used before. System.err is standard output for errors. In our case, system.err and system.out both output to the console. If you're working in a production client-server environment, it's good practice to output errors to system.err. These messages get displayed even if system.out messages get redirected to a file or some other output stream. Configuring standard streams to different output sources is more common in a client-server environment. I'll run this code again. Now I've got SQL state equals 42,000 and error code equals 1049. And the message is unknown database storefront. I'll go to a browser and type wiki SQL state. This brings up the Wikipedia page for SQL state values. Here, I'll search for 42,000. The message for this code is syntax error or access rule violation. Since these are standard codes, it's a good idea to try to use these if you can versus the database vendor code. For this scenario though, that code is not super useful. We don't really know if we have a syntax error, it's an access issue, or the schema just doesn't exist. Now let's look up the MySQL error code. I'll pull up the server error reference page on MySQL's documentation. I'll search for 1049. And here you see the MySQL string code, and that's followed by the SQL state 42,000. This is followed by a specific message, unknown database, which was printed in the exception we got. Let's search for 42,000 on this page. You can see there are many errors that fall into that state. I'll change the code to test the more specific MySQL error code. First, I'll set up a constant on my class. I'll call this MySQL DB not found and assign that 1049. Next, in my exception clause, I'll test both the database product name and the error code. If my database product is MySQL and the error code is 1049, then I know for sure the schema doesn't exist in the MySQL server. I'll remove the return false statement and replace it with the following code. I'll use getMetadata and chain the getDatabase product name to that and compare that value to the literal string value, MySQL. Additionally, I'll check if the error code equals my SQL DB not found's value. If both these conditions are true, then I'll return false, meaning the storefront database doesn't exist. Otherwise, I'll propagate the error out to the main method. This code doesn't compile though, because I need to catch or specify, so I'll include the throws SQL exception in the method declaration. I'll just add that manually. Let's run this again. I get the same result, but now I have confidence that I know exactly what the problem is. I wanted to spend a little extra time with SQL exceptions because it's important to understand as much about the error as possible that's returned from the database server. Okay, so let's create the storefront now. I'll create a new method that'll be private and static, returns void, and I'll call it setUpSchema. It'll take a connection, throwing an SQL exception. Remember that for my SQL, the terms database and schema are used interchangeably, so the first statement I need is create schema storefront, which will create the storefront database when executed. My first table is the order table, so I'll have a create order string using a text block. The DDL I need is create table storefront.order followed by an opening parentheses. That's followed by a list of columns and types. My first column is order ID, an int, it can't be null, and it's going to auto increment. Next, order date, a date time field, and again that should never be null. I need to specify the primary key, which is order ID. A closing parentheses ends the column list, and that's all I need to create this table. I'll add a second table that has a relationship to the first, named order details. This will be similar to the code for order. So create table storefront.order_details left parentheses. The order detail ID, an int, can't be null and gets auto incremented. Item description is a text field. The third column is order_ID. This is the column that connects the two tables. My primary key is order detail ID, but there's another key, a foreign key. It's pretty common to prefix a foreign key with FK, so I'll call it FK_order ID. This foreign key is on the column order ID. Next, I have to describe what's called a constraint. This describes both the relationship to the other table as well as limitations or constraints on table processing. So order ID in this table references order ID in the parent table storefront.order. This time, I want to delete to cascade to its child records. This code will set up a parent-child relationship between these two tables. And importantly, they're treated like a single unit when I delete the parent. This means if I delete an order, the details will also get deleted. Don't worry if you don't understand all of this SQL code. My goal here is first to show you that whether you execute DML or DDL, the process to do it in Java is the same. There is one significant difference I want to note, however. You can't roll back many of the DDL statements, so it's less common to execute DDL in a transaction. Whether or not you can execute DDL statements in a transaction is something that's specific to the database vendor. The second objective of this exercise was to give you a schema for upcoming challenges. Now, I have to add the code to execute these statements. I'll use a try with resources again. Creating a statement within that. I'll print that this is creating a storefront database. I'll call execute on my create schema first. I'll double check that it really got created by calling check schema. If that's true, I'll create the order table. I'll print that it was created. I'll execute the creation of the order details table next. And I'll again print that it was successfully created. Otherwise, I'll catch the exception and print it. I'll add the call to this method in the main method. I'll put it in the if statement after the system.out.println statement. I need to pass that the connection instance. Before I run this, I'm going to first open a session in my SQL workbench for my dev user. I used the workbench to independently confirm the schema and tables got added. Getting back to IntelliJ, I'll run my code. Everything seems to have worked fine. I get that the application successfully created order and order details and that the storefront schema was created. jumping back to my SQL workbench, I'll refresh the schema panel. The refresh icon is on the right of the schema's label. When I click on that, I should now see the storefront schema listed. I'll expand that and I'll expand tables, and there I can see my two tables that were created by the Java code, order and order details. If you have any problems at all with your own code, you can right-click on the storefront schema in this tool and select Drop Schema, then try your Java code again to recreate the schema from scratch again. Okay, so I'm going to bring this video to a close. Hopefully you were able to follow along and you've got a storefront schema set up and ready to be used. In the next video, I'll have a challenge using this schema, so keep this project open.